we should be visit dear Professor John McCarthy, who is the father of that concept, and we should be saying that that field is just a science and engineering of making intelligent machines. Of course, there are many wider definitions for explaining the concept of AI and explaining the field of AI, but we can just briefly say that it's the science and the engineering of making intelligent machines. You can do that by applying algorithms to the hardware side or software side. Of course, the hardware needs the software side to be run. Controlled algorithms. And we can say that it's just somehow a simulation of humans, animals, and nature. The AI can be also defined as the technology-based intelligent solutions briefly. And we can say that we use that field for improving effectiveness and efficiency in especially real-world problems. And because it's very effectively applied in all different fields and all different levels of the different real-world problems, we can say that it's the science of the current world and of course of the future. So that's very remarkable thing because the field of AI has a multidisciplinary scope, so it affects all the fields for now and for the future. And we can say that it's an interface between human and machine, and it includes, of course, mathematical and logical algorithms to run effective solutions for the real-world problems. And everybody says that if it's an utopia or not, and also it's very important that if it will be effective for every field. So it's very remarkable that it's both called as a utopia and dystopia, but time will be giving enough idea about if it will be a dystopia for the humankind, if it will be a technological risk or threat for us. And of course, we will be understanding in the next time period if it will be cause of existence. So that's actually related to humankind because we just the creator of the AI, and the AI is the product by the humankind. So we will be having the responsible for the future about talking about if the AI will be utopia or dystopia. And it's not a science evolving by its own efforts because it's a multidisciplinary and interdisciplinary science. It's not a stable technology. It's a very high momentum gained technology for the current and the future of the world. And that's because it's a very wide scope in terms of different fields. As you can see, there is the AI group you can see with the yellow line, and there is the machine learning, and inside that there is deep learning. So we can say that not every AI techniques are also machine learning, but all machine learning techniques and are also techniques of the field of AI. We can just say that you just divide main algorithms or techniques of the AI into two main groups, which is called as machine learning, and which is called that the other algorithms which have not learning abilities. For example, optimization algorithms, swarm intelligence, and maybe fuzzy logic are just not machine learning techniques. You just use them to run the exact algorithm in iterations in order to derive some values or some results at the end. So such algorithms doesn't need or do not need learning phase, but the machine learning and of course deep learning needs learning according to the target problem. So after teaching your algorithm the exact problem, you will be able to run it for different cases you have not encountered during the testing or training phase, for example. So that's machine learning and deep learning are just a subgroup of the field of AI. And when we talk about the multidisciplinary scope, we can say that there is the data processing, which is very important, supportive of the field of AI. We can talk about image processing for signal processing, as you know, and by using them, we just filter the data and make some data for the machine learning to make the machine learning technique to be learning better about the target problem. It's just something like that. We just read some books and also listen to our professors to learn better about the same thing. For example, if you think about a specific course. And as like that, the machine learning always needs some pre-processing steps, and the data processing is a very important component for that. And of course, today there are robotics and data mining and electronics or cybernetics or communication technologies, which are very important for the future of the AI, and also important developments for the current state of the field of AI. And of course, the multidisciplinary scope of the AI is a very deep topic. So that may be another speech topic. So I will just deep into more to the deep learning, to the scope of the deep learning, because our presentation is based on deep learning and cancer diagnosis. So maybe next time a more detailed presentation I can give to you for explaining more about details of the AI, for example, fuzzy logic or swarm intelligence. But for now, we should be knowing about what is machine learning and what is deep learning in terms of especially cancer diagnosis. As I've just said in the previous slide, the machine learning is just a collection of algorithms or techniques which are able to learn something about the target problem by using some data sets, for example, or some data or instant data coming from the environment by just thinking about the reinforcement learning, for example. So your algorithm will be able to learn something about some past state of the target problem, and after that you will be able to use your trained algorithm for new cases of the same problem. It's just something like that. You are going to school, going to university, you are listening to your professors, reading to some books, and trying to gain some knowledge and abilities regarding the target problem. And after that, you just take some examinations in order to see, in order to be tested if you have learned enough about the target problem. And after that, you graduate for being a doctor or for being a artificial intelligence engineer or data scientist. So that's very similar in the context of the machine learning, but as different from the real world, from humans. You just use some specific algorithms to pass through training, testing, and after that reaching to the application phase for your target problem. And we can say that, of course, the machine learning has been evolved into many different techniques and many different developments and changes during the last decade, or during the end of the 20th century and after the start of the 21st century so far. And we can say that the traditional machine learning techniques like artificial neural networks, for example, were not able to deal with big amount of data, very advanced and detailed form of data. So that was a very important problem, because you were not able to run exact such machine learning techniques to deal with the big amount of data. It may be taking days or months, and maybe causing some, for example, infinite loops and crashes in your system when you try to deal with the big data. But that was especially because of not very detailed techniques and because of mainly hardware requirements. But after the start of the 21st century, costs for the hardware components and also improvements regarding especially GPU, which we can say graphical processing units, we just reached to new advanced forms of machine learning techniques, and also especially new forms of neural networks, and we came to more and better and more effective analysis of big data, thanks to a more advanced form of new machine learning techniques. And briefly, we just started to call such collection of techniques as deep learning. Deep learning means you just deal with more deeper side of the data, and such data is just a big amount or complex structure of data, or unbalanced data and unstructured data. So deep learning is just a subfield of the machine learning and a collection of more